Good afternoon, everyone. So let us resume the session now. So before the break, we were discussing about the few basics of machine learning, artificial intelligence, generative AI. So now I'll share an experience about a course which is available for free in Infosys Springboard on the title Applied Generative AI. So I request all the participants, if you are interested, there is a free course available in the Infosys Springboard, which has got a proctored examination. So you can very well take up the exam and you can earn a certificate of achievement. So let me show the certificate which I have acquired already in Springboard. Actually, it has got 4 modules. See here. At the end, you will receive the certificate of achievement. Certificate of achievement, which is a certificate which is issued after the proctored examination. So applied generative AI. The certificate name is applied generative AI. It has got 4 modules. First, we need to complete 4 modules. First is introduction to OpenAI GPT model. So if you complete this course, you'll get a course completion certificate. And second module available there is prompt engineering. If you complete this, you'll get a course completion certificate on it. And third module is applied third one is AI for software engineering. There's a third module available there. Once you complete it, you'll get a course completion certificate. And fourth one is OpenAI generative pre-trained transformer version 3 for developers. It's a fourth module. So if you complete it also, you'll get a course completion. After completing all the course completions, you'll take up a proper examination which will be enabled. When you successfully clear that examination, you will get a certificate of achievement. So this awareness I'll give, which is available for free in Infosys Springboard, for which I request all the participants to go to Infosys Springboard. This is actually already a faculty enablement program given by Infosys as a part of knowledge enrichment. So go to this and then search for applied generative AI. I hope the participants are following the instructions. Now here it is showing only the course, but you have one certification course on it. Click on it. Here you can see that applied generative AI. So these are the 4 modules which I have shown. Prompt engineering, open, generative pre-trained, introduction to open AI GPT model, and fourth one is introduction to open GPT model. So when you complete all these 4 modules, then you will be eligible to take up the proctored exam and then you will receive a certificate. So first I'll show the 4 modules overview. You can see the status is open. I hope everybody have logged into this and identified this applied generative AI. So let us first enter into the first module. So after entering into this AI for software engineering, or you can go with this order. First module is introduction to OpenAI GPT model, first module. Here are the contents. See here. So for every content there is a video. And listen to this video. And then in between you will have short assessments. You have to complete these assessments. Next followed by video. Again an assessment, demos, some code, PPT scenario, again video. So parallelly in the left hand side you can see whenever you complete you can ensure a double tick pink color here. Now since I did not do anything, I'm skipping it. I'm not checking, I'm not visualizing any double pink color here. For example, if I complete this, let me show you. This video, if I complete now, listen completely. If I listen, understand this video, then you should leisurely listen to this video course. Then can you see here double tick after this language model? Similarly, when you complete everything, you ensure that all the things you are exploring, and finally ensure that all the contents are double ticked here, and then start attending the assessments. Okay, so start attending the assessments. After in between small assessments, finally, if you complete this first module, you'll have a self-assessment here. This is the self-assessment for module 1. So here you'll take up the test like this, and after finishing the test, you should give finish test. So you can, since I did not attend anything, I am getting this. This is the first module. Similarly, you have second one, which is prompt engineering. You can check the contents here. You have similarly explanation about generative pre-trained LLM, large language model, understanding language model, and then prompt engineering, why it is required, what are the concepts, and then guidelines. So there you have different things like what is the prompts. You can categorize the prompts as 0 shot, 1 shot, few shot, and how to give the prompts, how to design the prompts. Guidelines are there, and then you have to attend the assessment. After attending the assessment, you'll have the introduction about text classification, NLP. So everything you have to explore. You have to explore everything. Only if you complete everything, then you will be eligible to take up the final proctored examination. So here are few again in between small assessments, multiple choice assessments will be there. It will be very interesting. The course will be very interesting. Prompt engineering will be really interesting to you. And similarly, the demo code generation and all you have to view. To completing, parallelly ensure that the double tick you have here, meaning that you are completing the entire second module. After the second module, you have again this is not proctored, but this is one main assessment. After completing this, as I told you, you will get the second module certification. I have shown, right? Second module. This is module 2, prompt engineering. AI for software engineering. First module is introduction to OpenGPT. Second is prompt engineering certificate you will receive. So as soon as you complete, you can download the certificate from here. Once you complete, your certificate will be available. So similarly, you can do the third AI for software engineering, third module. See here, you have the pink line is not enabled here, right? Once you complete and finally you are attending the final assessment, the status will become dark pink, and here you can click and download your certificate. You have to explore the contents. You have to start again all the contents. You have to explore, listen to the videos, attend the small assessments. In between, see here, for example, if you take the AI software development lifecycle phase now, here itself you have how many assessments? Here 1 quiz, 2 quiz. Similarly, every submodules have its own small quiz having 2 to 3 or 4 or 5 questions. After attending all the things and studying everything, finally, final assessment of this third module you have to take. So once you complete it, you can download your certificate here itself and download it. This is module 3. Next is the last module, GPT, version 3 for developers. Again, here if you check the contents, see here, GPT-3 architecture, like it will contain The generative AI concepts here you'll have like what a sequence to sequence learning, that is LSTM concepts you will have here. What is a large language model, sequence to sequence learning, why RNN, the traditional thing is RNN. Here we'll just enter into some sort of technical content. So, what is the drawback of LSTM? Why we go for from RNN, why we move to LSTM? And then what is the drawback of LSTM? Again, why we go for transfer learning? Morning we were discussing. And again, then transformer architectures will come across. These are some of the internal concepts here. Again, a small assessment. So now transformer models. There are certain drawbacks of that LSTM. So we enter into transformer architectures. So description about the encoder and decoder part and what is the significance of the self-attention mechanism, multi-head self-attention. So technical concept will come in this particular module, the last module. Again, a small assessment. So after completing everything, ensure that here, see here, since I have opened it, just it is showing it, but you have to listen, read, and then attend the assessments. Finally, you have a self-assessment for this fourth module. So after completing everything, all the 4 modules, once it is completed, then you can see here yes, here you have overview contents discussion, right? Apart from that, here you will have one more tab called take the test. Once completing all the 4 modules, once that is enabled, you can take the proctored exam test. Like your video, everything will be monitored, and based on these 4 modules, the questions will be there. So if you clear the test, you will receive the final certificate of achievement. This achievement certificate, rest others are course completion. Finally, you will get the certificate of achievement. So this is a very good initiative offered by Infosys Springboard for learners like us. You can explore. Similarly, apart from this, you have a lot of other courses. Even machine learning, recently they have launched machine learning and NLP. But registration is closed for that. Since I have already registered, I am able to do it. This is FDP. Status is completed. I will show mine. So this is currently it is registration is closed. You cannot take it up. Already I have registered, so I'm doing it. I have completed this explore machine learning using Python, and I have received the certificate of completion. If I complete the explore machine learning using Python, if I complete the rest of the 2 also, totally 3 are there. Python for data science, explore machine learning, natural language processing for developers. I have to complete the rest 2, and then I'll be eligible to take up the assessment, proctored assessment. Then I'll get the certificate of achievement for faculty enablement program on machine learning and natural language processing. So similarly, you can search for lot many courses. Whatever courses you need, you can search in this Infosys Springboard, and you can start doing your course. So I hope you all have enrolled in the course and you have started doing the course, applied generative AI. Dear participants, I hope that everybody are doing the instructions regarding the course. If you have any issues in enrolling into the course, kindly text in the chat window. So I've given the basic overview and awareness about the course on applied generative AI. I hope that the participants are doing the course. They have successfully enrolled into the course. If you have any issues, kindly message in the chat window. I repeat again, the participants are given the instructions regarding the completion of the course. I have muted to the queries in the chat window. Okay, I hope. So I hope participants are doing, and here offline participants already they have completed module 1 and received their certificate, and second module they are doing in progress. So I'll give an overview of machine learning, which is a part of the another certificate of faculty enablement program on machine learning and natural language processing. So types of machine learning already we are aware, and here the different applications or the categories are supervised already visa classification, regression, everything. Now I'll skip the basics and show how to build a model and how to ensure that this model is working better than the other models. So this is the machine learning process already we saw. We'll have historical data, we'll do the feature engineering, that is extracting the features. After doing everything, we'll divide the data set into trained data and test data. So based on the trained data, we'll build the ML model, and that model will be validated using the test data, and then we will ensure the performance of the model using the metrics. If it is a classification application, the metrics are accuracy, precision, recall. And here, so before entering into regression, I'll explain about the metrics. I let us see offline participants to listen here. A small metric discussion. Offline participants, a small metric discussion. In the morning, I was telling about the metrics for evaluating the performance classification or accuracy, precision, recall, and regression or the mean square errors. And now coming here, you have another thing to measure or check the performance of an algorithm called confusion matrix. So where we classify the data, actually predicted data with respect to the actual data as the terms true positive, true negative, false positive, false negative. The entire data set is divided into these four categories. So true positive means the data is actually true and it also has been predicted as true. False negative means actually the data is true, but it has been predicted as false. So it is false negative. It is not a negative data. It is actually a positive data. So this is termed as false negative. Next, second category, actually it is negative, but it is predicted as positive. So this positive is not a true one. So it is called as false positive. Last category is true negative. Actually, the data is negative and it also has been predicted as negative. So let us look at this example. See, participants, can you answer here? Let us take the example of the spam classification, mail as spam or not spam. So totally when you count the total number of data here, 40, 50, 50, 100, in the data set you have 100 records. So out of the 100, actually 40 are correctly classified as spam. Really they are spam and they are also predicted as spam. But 10 are actually spam but predicted as not spam. Similarly, actually not spam but predicted as spam is 5. Correctly negatively predicted as 45. So how will you measure the accuracy in a total number of correct predictions divided by, total number of correct predictions divided by the total number of predictions. So here can you say how many predictions are correct predictions? Can anyone answer? How many predictions are correct here? We have 100. Out of 100, 40 are true positive, 10 false negative, 5 false positive, 45 true negative. Accuracy is nothing but total number of correct prediction divided by total number of prediction. Here correct prediction is 40 plus 45. 85. Total number of prediction is 100. So what is the accuracy? Can anyone answer? Can anybody answer here? So it is 80 divided by 100. Total prediction is 100. Correctly predicted is 80. Sorry, 85. So 85 divided by 100. So we can call it as accuracy is 85 percentage. So this is a formula. So now our model will undergo a problem called overfitting, in the sense that already we saw that few set of data are used for testing and few are used for training. So when your model will undergo overfitting is that it will perfectly work well during the training phase. For each and every record of training, it will correctly do the classification. But when new set of instances are coming for testing, it will not perform well. So in that scenario where your model is perfectly doing well during the training, but it is not perfect during the testing, then your model will undergo the problem. The problem is called as overfitting. So if you take the decision tree, how to address this overfitting now, the decision tree will be very deep. So many number of branches will be there. In the sense that it will not generalize. The learning will be specific, not general. To avoid it, if you take, for example, a decision tree algorithm, there you can restrict the depth of the tree. Beyond this depth, the tree should not grow. So in that case, you can avoid overfitting. Similarly, you can prune or you can delete certain branches of the tree. I hope you are all aware of decision tree. So by with respect to that, I'm telling how to overcome the overfitting. Now, can anyone answer what is a evaluation metric best suited for classification problem? Is it accuracy or mean square error or R square error or all of the above? Yes, very good, accuracy. Yes, sir. Second time you answered well, sir. No, sir. No issues. Yes, sir. Regression. Yes, ma'am. Good. Now, in second question, in supervised learning, the model learns from their choices are there.
Not audible.
Sorry, the data set contains the different entries. So based on the single data set, let us develop three models. Assume that using the regression, first let us consider only the mean. For model 0, let us consider only the mean for calculating the time taken to repair. Because it is a regression model, we are going to calculate the time taken to repair a computer, wherein the mean factor alone is going to be taken. And model 1, the same problem. In model 1, we are going to consider two values, beta 0 as per the equation. Beta, here it is, beta 0, beta 1 and beta 2. So here beta 1, beta 0, let us assume that 10, which is nothing but the startup time. That is the time taken to understand the repair work to be done. So to finally calculate the total number of time, let us classify two features here. First one is the time taken to understand how much time will this particular repair task will take. And second parameter is noted here as beta 1. This is the time taken really to replace a single unit. Similarly, n number of units will be there, right? So 12 into, suppose 2 units, so 12 into 2. So 10 is nothing but forecasting like the pre-work time, how much time it may take to analyze everything. So here we are taking two parameters into account, but in this model, we are not considering two parameters, only the mean of the time taken we are going to consider. So this is a simple explanation. Assume that for the same problem, we are building three models using the regression algorithm. Model 0 considers only mean. Model 1 considers like two parameters. One is the pre-work time, expected time, and other one is the total number of units. So model 2, the same two factors are considered, but in different values. This is how the model differs, right? The parameters based on the hyperparameters, the model will differ. So three models we are building. So code is also given here. You can execute it later. So when you visually view all these three models, this red color line is model 0, since it uses only the mean, and black color and is model 2, and green color is model 1. So performance, when you visualize this, model 1 and 2 are better than model 0. So this is the data set. Actually, this is a predicted time. What is meant by error? Now, the difference between the actual time taken to repair the computer with respect to what time we are predicting with respect to the model what we have built up is the predicted time. For example, there are only one unit, faulty unit. With that unit, we are expecting that it will take some 97 seconds. But actually, when you started repairing, it is taking only 23 seconds. So here the error is nothing but the difference between the predicted time and the actual time. So this is the performance output of model 0. So here we express it in terms of an error called sum of squared errors, SSE, which is 27,768, because the data set, the average mean only we are considering. Similarly, this is the output of model 1 performance. So for example, if you take, see here, in this, suppose one faulty unit is there, actual time 23, predicted time 97. Whereas if you take model 1, actual time is 23, but it is predicting 22, very close to the actual time. The predicted time is very close. Error is very, very low, -1. But in this case, error is 74, very high. So model, similarly, we are analyzing the performance of model 2 and we are checking the error mean square. This mean square error is 5001, and here for model 1, the mean square error is 4993, whereas model 0 showing the error of 27,000, which is very drastically huge error. So this is the comparison of these three models for a simple task of calculating the expected time to compute the to replace the affected parts of a computer. So here in this model we are taking this assumption, so but it is showing poor result. Second, model number 1, we are doing some modifications. Third, this is how we used to compare the models and say that this particular model works better for this case study. So next is regarding the feature engineering, how to select the features, how to say I've given the source code of everything. You leisurely run the source codes in your Google Colab and ensure it. So first is selecting the features. So here we are not doing any using any data set. Then we are using the pandas. As already told regarding the machine learning model, feature engineering, first you do it and then splitting the data into, see for which you have certain methods. In the upcoming sessions of the next days, you will encounter this. This is testing data splitting. See, point 2 in the sense 20% of the data will be taken for testing and the rest of 80% will be taken for training. Finally, we are building the model for evaluating the performance, root mean square error, because it is a regression problem. We are making use of root mean square error. So prediction accuracy. Similarly, another task is for classification. Here again, logistic regression. So code is there given. Same thing, measuring. Whereas here logistic regression is a classification algorithm. So the metric differs here. So previously we saw about regression algorithms, the metrics are error metrics. Whereas for classification algorithms, the performance metrics are accuracy, precision, recall, and F1 score. So here we saw like false positive, true positive, false negative, and true negative. So precision indicates how accurate the model is. This is the formula, number of instances correctly predicted divided by total number of instances predicted as A, like spam or not spam, anything. Similarly, recall. So based on the table confusion matrix only, we'll be calculating precision, recall, and F1 score. So this is how we used to project the results. So certain activities I've given here. And similarly, for classification task also, using decision tree, splitting the data. These tasks you can run and check the performance and you can analyze the performance of the models what you have developed. Using scikit-learn. So this is a decision tree visualization. See here you can see. For example, accuracy of the model on the training data is 100%. Whereas the accuracy of the model on the testing data is only 65%. So this model is undergoing overfitting because it is performing well during training, whereas it is not performing well during testing. So this is the scenario of overfitting. See 67% in your accuracy. So the model undergoes overfitting, which is not good for approximation. To avoid this problem, we can alter certain hyperparameters. Hyperparameters of decision tree is nothing but the depth of the tree, the number of branches. Okay, that sample splits and all, impurity decrease. Those hyperparameters you can alter, and after altering, you can check the performance. Next is k nearest neighbor. Next is support vector machine. Support vector machine, this is with respect to the classification problem. Here choosing hyperplane is nothing but the plane which intersects the two set of data with respect to its features. So identifying the best hyperplane is the problem in SVM. So here this boundary, these are all the boundaries. To call it as the margin lines. We have to find the optimal hyperplane here. Again, for building an SVM model, we'll be reading the data. So for this, we are using the iris.csv dataset, which contains the details of the flowers. The flowers details like the length of the sepal, width of the sepal, Length of the, so flowers will have sepals and petals. So width and length and width of the sepals and petals. Based on that, the species will be identified. Here, the species name is Setosa. Similarly, versicolor. This is a basic data set. So we have to first read the data set. So importing and visualizing the data, then doing the feature engineering, visualizing it. So classification itself, we have two categories, one class classification and multi-class classification. One class in the sense the binary classifier, yes or no. Multi-class in the sense whether the flower is X, Y or Z. This is multi-class. So another concept is boosting, which is an ensemble technique which combines the algorithms for better understanding. So running short of time, I'll give the codings. You just copy and run it in Google Colab. I hope everybody are aware of using Google Colab. Yesterday, I think that in yesterday's session, the use of Google Colab has been introduced. I hope participants can use the Google Colab and run and check the model, its performance, and then finally identifying which model is better. So I hope participants are here, offline participants are successfully completing their modules. Online participants also, I'm expecting the same. You cannot complete the task within a day, it will take some time. But proctored exam, you sit it in a separate place with camera, take up the test, successfully complete and receive the certificate of achievement. I wish all the participants to complete this course and receive the certificate of achievement.